Hi everyone, welcome back to this video series on cryptocurrency. Independent verification of transactions. In chapter 6 we saw how wallet software creates transactions by collecting UTXO, providing the appropriate unlocking scripts, and then constructing new outputs assigned to a new owner. The resulting transaction is then sent to the neighboring nodes in the Bitcoin network so that it can be propagated across the entire Bitcoin network. However, before forwarding transactions to its neighbors, every Bitcoin node that receives a transaction will first verify the transaction. This ensures that only valid transactions are propagated across the network, while invalid transactions are discarded at the first node that encounters them. Each node verifies every transaction against a long checklist of criteria. The transaction's syntax and data structure must be correct. Neither lists of inputs or outputs are empty. The transaction size in bytes is less than max block size. Each output value, as well as the total, must be within the allowed range of values, less than 21 million coins, more than the dust threshold. None of the inputs have hash equals 0, n equals 1. Coin-based transactions should not be delayed. N lock time is equal to int max or n lock time, and n sequence values are satisfied according to median time passed. The transaction size in bits is greater than or equal to 100. The number of signature operations (SIGOPs) contained in the transaction is less than the signature operation limit. The unlocking script SIG can only push numbers on the stack, and the locking script pub key must match its standard forms. This rejects non-standard transactions. A matching transaction in the pool or in a block in the main branch must exist for each input. If the reference output exists in any other transaction in the pool, the transaction must be rejected. For each input, look in the main branch and the transaction pool to find the referenced output transaction. If the output transaction is missing for any input, this will be an orphan transaction. Add to the orphan transactions pool if a matching transaction is not already in the pool. For each input, if the referenced output transaction is a Coinbase output, it must have at least Coinbase maturity 100 confirmations. For each input, the reference output must exist and cannot already be spent. Using the referenced output transaction to get values, check that each input value as well as the sum are in the allowed range of values, less than 21 million coins, more than 0. Reject if the sum of input values is less than the sum of output values. Reject the transaction fee would be too low. Min relay TX fee to get into the empty block. The unlocking scripts for each input must validate the corresponding locking scripts. These conditions can be seen in detail in the functions accept to memory pool. Check transaction and check inputs in Bitcoin Core. Note that the conditions change over time. Address new types of denial of service attacks, or sometimes to relax the rules as to include more types of transactions by independently verifying each transaction as it is received, and before propagating it, every node builds a pool of valid but unconfirmed transactions known as the transaction pool, memory pool, or mempool. Mining nodes. Some of the nodes on the Bitcoin network are specialized nodes called miners. In chapter 1, we introduced Jing, a computer engineer student in Shanghai, China, who is a Bitcoin miner. Jing earns Bitcoin by running a mining rig, which is a specialized computer hardware system designed to mine Bitcoin. Jing's specialized mining hardware is connected to a server running a full Bitcoin node. Unlike Jing, some miners mine without a full node. Like every other full node, Jing's node receives and propagates unconfirmed transactions on the Bitcoin network. Jing's node, however, also aggregates these transactions into new blocks. Jing's node is listening for new blocks propagated on the Bitcoin network, as all do the nodes. However, the arrival of a new block has special significance for a mining node. The competition among miners effectively ends with the propagation of a new block that acts as an announcement of a winner. Two miners receiving a valid new block means someone else won the competition and they lost. However, the end of one round of a competition is also the beginning of the next round. The new block is just a checkered flag marking the end of the race. It's also the starting pistol in the race for the next block. Aggregating transactions into blocks. After validating transactions, a Bitcoin node will add them to the memory pool or transaction pool, where transactions await until they can be included and mined into a block. Jing's node collects, validates and relays new transactions just like any other node. Unlike other nodes, however, Jing's node will then aggregate these transactions into a candidate block. Let's follow these blocks that were created during the time Alice bought a cup of coffee from Bob's Cafe. Alice's transaction was included in block 277316. For the purpose of demonstrating concepts in this chapter, let's assume that block was mined by Jing's system and follows Alice's transaction as it becomes part of this new block. Jing's mining node maintains a local copy of the blockchain. By the time Alice buys a cup of coffee, Jing's node has assembled a chain up to block 277314. Jing's node is listening for transactions, trying to mine a new block, and also listening for blocks discovered by other nodes. As Jing's node is mining, it receives block 277315 through the Bitcoin network. The arrival of this block signifies the end of the competition of block 277315 and the beginning of the competition to create block 277316. During the previous 10 minutes, while Jing's node was searching for a solution to block 277315, it was also collecting transactions in preparation for the new block. By now, it has collected a few hundred transactions in the memory pool. Upon receiving block 277315 and validating it, Jing's node will also compare it against the transactions in the memory pool and remove any that were included in block 277315. Whatever transactions remain in the memory pool are unconfirmed and are waiting to be recorded in a new block. Jing's node immediately constructs a new empty block, a candidate for block 277316. This block is called a candidate block because it is not yet a valid block and it does not contain a valid proof of work. The block becomes valid only if the miner succeeds in finding a solution to the proof of work algorithm. When Jing's node aggregates all the transactions from the memory pool, the new candidate block has 418 transactions with a total transaction fees of 0.0909498 Bitcoin. You can exceed this block in the blockchain using the Bitcoin Core client command as shown in figure 10.3. So here we go. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.